Okay, this is for my drinking water colleagues out there who are interested in learning a little bit more about chemical dosing for the advanced exams, but also this is something I run into every day in the summertime and at least weekly during the winter because I have a chloraminated drinking water tank. And one of the dangers of long detention times with chloramines is nitrification. So if you are unaware of that and you are taking an exam, you need to know what nitrification is and its dangers. Nitrates lead to methaglobinemia, I think is how it's pronounced, blue baby disease, and it's really dangerous for pregnant women and babies. I will not get into the science of it, but it is our job to make sure that that does not happen. So when I am doing my rounds on a typical summer day, two things I check for, and I have a Hawk colorimeter that with reagents, I can test this in the field. I take grab samples from the tank every day and I test for nitrite and I test for free ammonia. And my objective is to neutralize the nitrite, oxidizing it with free available chlorine that I'm going to dose into the tank, sodium hypochlorite, oxidizing that and then binding the free ammonia to create more chloramines. This works very well, okay? Why you want to get rid of these, by the way, is they turn into nitrates over time. There's a biological process going on in the tank, by the way. These are bacteria that feed on ammonia and they convert it to nitrite and nitrate. Okay? So what you're doing here is getting rid of this before it becomes a problem, and you are binding this so that you're starving, theoretically starving the bacteria. But there are times, and I'll say this before we get into the math problem, that no matter how much you do this, it still rears its head at you and you've got to break point the tank. I mean, you do your best, and then you never know when you come into work and go, oh crap, my chlorine residual's tanking, my pH is dropping, and when I see that, I don't wait for too long. I go ahead and break point the tank, go free available, and let it sit there for a couple weeks at the free available, and that kills the biofilms, and then you can convert back to chloramines. Okay, so that's a little conceptual. If you guys out there have anything to add to this conversation, I do not want to pretend like I am the end-all be-all of knowledge on this. I just deal with it, and I know how to deal with it. But if you deal with it in a different way, hey, please let me know. I'd love to hear it. I'd love to build community. Please put it in the comments. Let's have a discussion. Okay, so this is how it's going to show up on your test. You're going to get dimensions of a tank. I don't know if you're going to be asked this on a higher level test, but you need a concentration because you're going to be doing a dosing calculation. And you're going to be given all this stuff to figure out what your pump timer should be put on in minutes. Okay, this is how we do it here anyway. And the thing about water tanks is any modern water tank has a tag on it. You can just walk up and figure out how many gallons per foot you have, but they're not going to go that easy on you on a test. And you know what? Sometimes there are no tags and you got to figure it out. So let's figure it out. You're given a tank with 70-foot diameter. Sorry. You're given a tank that has a 70-foot diameter. Its overflow is at 23 feet. The current water level is 16.5 feet. My grab samples from the tank show that I have a 0.03 milligram per liter nitrite level, 0.35 milligram per liter free ammonia level. And I'm going to be using a pump that feeds at 80 gallons. I didn't write the variable there, or not variable, the unit. Sorry, 80 per day. There you go. 80 gallons per day. I'm going to be feeding sodium hypochlorite that's got a concentration of 12.5% and a specific gravity of 1.2. What is my pump timer I'm going to set in minutes? Okay, the first thing I want to say before we start working the math out is I have a mixing device in my water tank. I have a Solar Bee. Before you start going and doing stuff like this, by the way, talk to your chief operator. Get their take on this. I am not here to tell you how to do your operations. I'm here to tell you what I do, and hopefully it gives you ideas or helps you on an exam, okay? So I've got a tank mixer. If you don't have a tank mixer, talk to your chief operator about how you're going to get that water mixed while you do this, because the last thing you want is a slug of chlorine in your water tank just sitting there. Okay, so first thing I'm going to do is find the volume of my tank. and that is 0.785 diameter squared times the height. By the way, I'm assuming you know how to do most of this if you're in an advanced chemical dosing math lesson. Go back to some of the other lessons on my channel if you're interested in some more basic math. So 0.785 diameter squared gives me 88,470 cubic feet. If you're curious about how I got that, please ask in the comments below. And 88,470 cubic feet times 7.48 gallons in a cubic foot is 661,752 gallons. So my overflow is 23 feet, but my tank level is 16.5 feet. I need to figure out how many gallons I have in the tank. So what I do is I divide the gallons of the tank by 23 feet, which is my overflow, max level, and that's 28,772 gallons per foot. So to find out what the volume is at 16.5 feet, I just take the gallons per foot and multiply it by 16.5 feet, and that's 474,735 gallons. Now I have my volume, and I'm just going to do it down there, but to get to million gallons, you just divide by 1,000,000. So yeah, I just actually don't have the space to do that, and I'm going to make an assumption that you know how to do the pounds formula and how to get things from gallons to million gallons. Okay, the next thing I need is my dose. So nitrite is 0.03, free ammonia is 0.35. Nitrite has a demand of 5-to-1 on chlorine. Ammonia has we won't really call it the demand on ammonia is 10-to-1, but we're not trying to eliminate it and oxidize it. What we're actually trying to do is bind it. So a 3-to-1 ratio of ammonia to chlorine will give you monochloramines. And so that's our target. So I say 0.35 times 3, because I'm looking for a 3-to-1 ratio, is 1.05. And so you just add those two together, and now we're at a 1.2 milligram per liter dose. Okay, so I have my volume in million gallons. I have my dose. I can do a pounds formula now. So 0.47 million gallons times 8.34 pounds in a gallon times 1.2 milligrams per liter gives me 4.7 pounds of chlorine that I need to feed into the tank. So we need to now get our gallons. 4.7 pounds divided by 10 pounds per gallon of chlorine. How did I get that number? 1.2, specific gravity. If you're curious about this, ask. But what you do is 8.34 times 1.2, and that gives you the pounds of chemical, pounds per gallon rather of chemical. So if you're confused about that, go back to some of my earlier videos, look at those. At the recording of this video, some of them aren't up yet, but they will be eventually, and I'll link to them. But if you have any questions, please ask. And then divided by 0.125, which is 12.5%. That's the decimal version. So 4.7 pounds divided by 10 pounds per gallon of sodium hypochlorite divided by 0.125 gives me 3.8 gallons. Okay, now I need to move it to the pump timer. So I now know how many gallons I need to dose into the tank, but I'm not just going to climb on the tank and dump 3.8 gallons in. That's asking for trouble, even with a tank mixer. So that would work if I was breakpoint chlorinating and I just needed a free available. It would eventually do it. But what I'm trying to do is a careful, like a targeted dose where I'm trying to combine with ammonia throughout the entire tank, not in just one area. So there's two different ways to do this. This is how I do it. You can also use 1,440 minutes in a day. I just find this math easier for my brain, so this is how I do it. I have an 80-gallon per day chemical feed pump, but I need to get it in minutes. So 80 gallons per day divided by 24 hours in a day, that will feed 3.33 gallons per hour, and I need 3.8 gallons fed. So what I do is I take 3.8 gallons divided by 3.3 gallons per hour, and that's 1.15 hours. That's how long I need to feed the chemical into the tank. Well, my timer on SCADA is in minutes, not in hours. So what do? I multiply 1.15 hours times 60 minutes in an hour, 69 minutes. So this works like a champ most of the time, and I'm able to get rid of that nitrite, and I'm able to bind that free ammonia. I see my chloramine residual go up, typically by about not the 1, but the 0.3. Like I'll see when it's bound together, the residual. It's not, right on the money because these are grab samples I'm taking. So it could be, these numbers could fluctuate especially, you know, over the next hour, water chemistry could change. But yeah, I have a lot of success with this. So I figured I'd put a video out for the drinking water folks, even though it's not the aim of this channel, to see if I can help folks. I always want to disclaim, talk to your chief operator. Don't do anything without their guidance and approval. But if you have any questions, please ask. I know I move fast through some of this math. I'm making some assumptions about your level of math if you're watching this. And if I left anybody behind, please let me know. And if you like this video, by the way, please subscribe to the channel and share with your friends and colleagues who are studying for exams. This type of math is not uncommon on higher level exams. Yeah, that's it. That's my little commercial for the channel. Have a great day.